Right, this looks long. Right, y equals r shine x. Differentiating that, no problem at all. Straight off the formula book. So we've got 1 over the square root of x squared add 1. Let's rewrite that as x squared plus 1 all to the minus a half. Now, differentiating that for a second time is just going to be a chain rule. So we've got x squared plus 1 times by the power goes down by 1, also got a times by the middle of the bracket there, and so that's not that bad, is it? So I've got minus x coming outside here, and then I've got x squared plus 1 all to the minus 3 over 2. Right, but we got to do it again. So d cubed y over dx squared. So we've got the minus x, that's going to be going to a minus 1. We've got the x squared plus 1 all to the minus 3 over 2, and that's going to be going to an x squared plus 1 to the minus 5 over 2. We're going to be timesing by the 2x and the minus 3 over 2. So I think that's going to be a minus 3x outside here. Oh, I hope I've not made a slip there. Right, so what is this going to give? It's going to give us minus x cubed plus 1 to the minus 3 over 2, and a minus minus there, so plus 3x squared, x squared plus 1 to the minus 5 over 2. Right, I think that's what it differentiates to give. Now let's, oh, you're kidding. Right, let's have a little look at what we're trying to prove. Right, so we've got 1 plus x squared times by what we just did, plus 3x lots of d2y by dx squared plus dy by dx. That's what we're trying to do. Okay, so 1 plus x squared times by that, what's that going to be? So we've got a 1 plus x squared, so we're just losing one of them then, aren't we? So we've got minus x squared plus 1 to the minus half. That's from that bit there. Then from that bit there, we've got 3x squared, x squared plus 1. It was minus 5 over 2. We're getting one of them up, so that's minus 3 over 2. Okay, so there's that bit. Then plus 3x times by, where is it? It's up there, isn't it? Is it still on the screen? No. Okay. So we're doing 3x times by that one. So that is minus now, because there's a minus here, minus 3x squared, x squared plus 1 to the minus 3 over 2. Well, that's good because they're going to cancel. And then finally, plus dy by dx. So dy by dx is all the way up there. So we've got x squared plus 1 to the minus a half. Right, let's come back to all of that. So that is the same as that. They cancel out. That's a positive 1. That's a negative 1. Equals 0. Phew. Now, of course, that sort of differentiating once, twice, 3 times is going to come in useful when we do Maclaurin expansions of these in a bit.